Back in December of 1972, astronauts Gene Cernan and Jack Schmidt were walking on the moon. This was Apollo 17, the last Apollo moon mission, and the goal was geology. Altogether, Gene and Jack gathered 741 rock and soil samples that geologists back home would be investigating for literally decades to come. And from these rocks, we found not only clues about how the moon came to be, but also clues on how the Earth came to be. The rocks looked in significant ways like they came from the Earth. Our story begins in a grand nebula of gas and dust. Gravity's hand here acts as master architect, gradually collapsing the cloud in an ugly, creative mess. As the grains combine and combat each other, some are flung far beyond these reaches, and some change their faces mid-battle, like crystals we find in rocks with high-pressure pasts. After around 100 million years of this mess, though, our solar system seems to have been stabilizing. And one of the planets in the cradle of that planetary nursery was the early Earth. But it seems it wasn't alone. A possible planet named Theia, maybe made of different material than early Earth, was its jealous sister. And hurtling around their formed orbits. Eventually, the early Earth and Theia were destined to collide. Waltz of the Worlds was so energetic, it may have vaporized both planets, mixing their cores as well as their mantles into a swirling liquid vapor jelly donut called a Synestia. At the edges of the Synestia, magma raindrops formed, only to fall back in towards the core, melting and perpetuating the short life of the Synestia. As the structure cooled and collapsed, it's thought that some of these droplets remained afloat, eventually accreting into our moon like a huge snowball emerging from a ball of fire. The moon's orbit was then right next to the Earth, and Earth was reeling, spinning with 5-hour-long days. But over time, the tidal force of the spinning Earth has accelerated the moon, flinging out its orbit. And when the moon was far enough out, its orbit gradually shifted due to the tug of the sun, aligning itself to the rotational plane of the Earth around the sun, called the ecliptic. During this gradual exchange of spin energy from Earth to Moon, the Earth's spin began to slow down to our familiar 24-hour-long days. And over millions of years, the Moon was then periodically bombarded by hundreds of large and small meteorites. These impacts kicked up tons of brighter material under the surface, like fresh snowpack frozen in time. And eventually, painting the shapes we now recognize as the face of the moon. The moon missions brought suddenly and irrevocably our friend in the sky a little closer to us in spirit. We know it now as a place where some have spoken and wandered and dreamed. And though our travelers came home as heroes, and their names will echo through the ages, their legacy is left to live on in the insights of our moon's origin and our intertwined place in that story. And what mysteries might still be hidden in the lunar regolith? Could continued exploration of the moon change the story yet again?
I was strolling on the moon one day in a very, very month of December. May, when much to my surprise, a pair of bunny eyes. Oh, is this a neat way to travel? Isn't it great?